Imagine one day the universe itself whispers, "No more." For billions of years, it has stretched and stretched, pushing galaxies apart, carrying time forward like a river that never turns back. But what if suddenly it stopped? What if the great cosmic dance came to a standstill? Welcome to the thought experiment. Today, we journey to the edge of everything we know to ask a question that could define the fate of existence itself. What will happen if the universe stops expanding? Why the universe expands? The universe is not a sleeping giant. It is awake, alive, constantly in motion. As each second ticks away, space itself stretches. Galaxies drift further apart, carried on invisible tides of time. But why? Some say time moves forward because the universe moves. Others say the universe moves because time refuses to stand still. Either way, they are bound together, woven like two strands of the same cosmic thread. This expansion has a silent architect: entropy, the natural drift from order into chaos. Entropy is relentless. It's why you can't unscramble an egg, why a shattered mirror never reforms. The universe, too, cannot simply reverse itself. But this wasn't always known. In 1929, Edwin Hubble looked up and saw galaxies racing away from each other. That single discovery cracked open a mystery that haunted humanity since the time of ancient philosophers. Is the universe infinite or finite? A cosmic paradox centuries earlier, Heinrich Olbers posed a chilling thought. If the universe were infinite, every direction you look would eventually end on the surface of a star. The night sky should be flooded with light. But it isn't. There are shadows, darkness, so the universe must be finite. But then Isaac Newton came along and shattered this neat conclusion. Gravity, he said, pulls everything toward everything else. If the universe were finite, its own weight should have made it collapse. And yet, it didn't. Why? Because the universe was already moving outward, expanding. That was its escape. This meant that once, long ago, everything was compressed into something unimaginably small, a singularity, a cosmic seed. But what set it free? The mystery of dark energy. Many scientists point to something invisible, untouchable, and utterly dominant: dark energy. It pushes galaxies apart. It fuels the expansion. But here's the twist. No one truly knows what it is, or whether it will remain the same forever. What if dark energy weakens? What if, one day, the push outward fades away? Then gravity, the oldest force in the cosmos, would take over again, and the universe would begin to fall. Time reversal symmetry. Interestingly, the laws of physics hold a strange secret: time reversal symmetry. This means the equations of the universe work just as well if time runs backward as they do forward. We've seen it in the dance of billiard balls, in magnets attracting, in the strong nuclear forces binding atoms together. In theory, if you knew every single detail about a moment, you could rewind it. But there's a catch. Entropy doesn't play nice. Break an egg, smash a glass. These are one-way tickets. Time flows forward. Chaos doesn't unmake itself. The thermodynamic arrow of time keeps pointing ahead, even when the universe itself might want to look back. Is expansion slowing? The universe is not expanding as wildly as it once did. In the fiery aftermath of the Big Bang, it ballooned with ferocious speed. Today, that rush is slowing. The cosmic fabric is cooling. It whispers a quiet truth: expansion may not last forever. If dark energy shifts, if the outward breath stops, then gravity will begin its work. Imagine the universe pressing rewind, not with time, but with space itself. Galaxies falling back toward one another, stars merging, light bending inwards. But don't be fooled. Even in reverse, time won't follow. It will keep moving forward into darkness. Entropy's final ACT. Even in a frozen universe, gravity never sleeps. Stars would collide. Matter would collapse. Black holes, those cosmic beasts, would grow fat on everything. Right now, the supermassive black hole at the center of Milky Way holds more entropy than the entire universe had a second after the Big Bang. And it's not alone. As the universe contracts, entropy will soar. Planets will fall into stars, stars into black holes, and black holes into one another. Everything will be drawn toward a single crushing point, a big crunch. And here, something extraordinary happens. The end of time. As we approach the event horizon of this final singularity, time begins to warp. Seconds stretch into eternities. A single moment lingers forever. It would be a cosmic race between collapsing matter and the final heartbeat of time itself. And then everything we've ever known would vanish into a singular point of infinite density. But is that truly the end? The next universe? Some theories suggest this big crunch could ignite a new beginning, a new Big Bang, a cosmic rebirth. Or perhaps there will be a silent pause, a moment outside of time, before existence dares to take another breath. And that leads us to the greatest mystery of all. If we could stand at the edge of the universe and stretch out our hand beyond the boundary, what lies on the other side? Tell us what you believe awaits at the end of everything. And as always, thank you for watching the thought experiment. If it changes, everything changes.